Code auditors and security researchers largely use a mixture of fuzzing and grep to identify security vulnerabilities in source code and bytecode. Security vulnerabilities in source code are parts of code which an attacker can exploit as a consequence of logical programming errors. And most common vulnerabilities are caused due to unchecked inputs. To exploit unchecked input, an attacker needs to achieve two goals. The first is to inject malicious data into web applications. Common methods used include parameter tampering, hidden field manipulation, HTTP header tampering, cookie poisoning, and more. The other goal is to manipulate applications using malicious data. And in this case, common methods used include SQL injection, cross-site scripting, path traversal, command injection, and more. Many attacks described in the previous slide can be detected with code auditing. Code reviews pinpoint potential vulnerabilities before an application is deployed in production. Code reviews, while recognized as one of the most effective defense strategies, are time-consuming, costly, and are therefore performed infrequently. On the other hand, security auditing requires security expertise that most developers do not possess. So security reviews are often carried out by external security consultants, thus adding to the cost. In addition to this, because new security errors are often introduced as old ones are corrected, double audits and a certain degree of automation is highly recommended. Speaking of process automation, which parts of the process should we automate? Identify parts of code that are vulnerable, ways in which user-provided data can enter the program, find ways in which user-provided data that enters can exploit any vulnerable condition, and thereafter identify or determine various vulnerable conditions that exist in the code. ShiftLeft introduces Ocular. Ocular treats code as a graph and allows contextual pattern-based analysis using semantic code property graph, which is an extensible and language-agnostic representation of source code, thereby allowing security response teams and developers to quickly and accurately explore code through simple queries to identify coding mistakes, which can lead to variants of known, unknown, and zero-day vulnerabilities, and seamlessly integrate results into workflow of developers and security response teams for on-demand and continuous security assessment.